Everybody, welcome to the channel again. Today we're going to go ahead and cover dimple dies. If you don't know what these are, we'll explain it in just a little bit here, but basically they're for putting, exactly like it says, dimples in sheet metal. A lot of this can be structural to increase the rigidity of a piece of sheet metal, and sometimes decorative, and sometimes even just to reduce weight in a particular part. And there's a lot of videos out on how to make these, but most of the videos that I've seen involve, putting them on your bench and hitting them with a hammer, or possibly placing them into a hydraulic press and using that. What I wanted to create was something that was easier to use in situ, as we say. So if you were working on an object that could not be inserted in a press, that you couldn't put an anvil behind to hit with a hammer, we're going to do these where they're hydraulically driven. And what we're going to use to do this is a hole punch, a hydraulic hole punch. This particular one came from Harbor Freight, and not that I'm shilling for one or the other. I don't have any sponsors or anything. I just happened to be in a Harbor Freight buying some sandpaper, and this was on clearance. They had 40% off clearance. It was ridiculously cheap. So now I have a hydraulic hole punch. And that will be nice. It helps with putting holes in metal cabinets and things. To date, I've been using various other methods. Hole saws, always a pain, but the hole punch is great. So what we're going to do is we're going to show you how to make this dimple die in your lathe. Now, for this procedure, you do need a lathe. You could do it by hand. It's just a lot more difficult, to get it all even. But we're going to use basically just two tools, okay, on the lathe, that is. We're going to use a drill bit for punching the center hole, okay, and we're going to use a boring bar. So that's all it is for the entire thing. So the neat part about doing this with just a single tool on the lathe is that we're not going to have to go and pick up our measurements over and over and over again. The only thing that really needs to be fairly accurate is the dimensions of the interior holes, because it rides on a shaft when it is doing the pressing. And then this outer circumference, and we'll get into that in a little bit, but basically that lets you fit the piece into the hole that you've punched. So I'm going to go ahead and go to the bench and kind of give you a little bit closer up view of these and how they work and how they go together. And then we'll get over to the lathe and I'll show you how to make one. It's really quick and easy. All right, so let's get to the bench and look at the parts. Okay, here we are back at the bench, and here's a close-up of the dimple die. It's in two pieces. We've got our registration boss on the outside here that helps center the die in the holes that we punch, and a 45-degree cone on each side that forms our dimple. I chose 45 degrees arbitrarily. You can do whatever angles you want based upon your use case, but 45 works for me. And I did a nice small shallow dimple with this one. Again, this can be modified very easily. Any lathe can do this. You don't need to have a high precision machine because these aren't necessarily high precision parts that we're making. We're putting dimples to either add strength to a piece of sheet metal or strictly decoration, whatever we need. So where this came from is obviously one of these hydraulic pumps and cutters. These are designed to put holes in sheet metal, generally used by electricians to punch holes in electrical boxes to put conduit in. So it comes with a whole set of these. And basically they're in pipe sizes, so they're a little bit off of standard dimensions, but for dimpling and creating these, fine, that works fine. You can put the hole with anything you want. You can make your die to fit anything you needed. The basic way that these work, and you see I've got a hole that I've punched and a hole that I've dimpled already. We'll go through and show you this in a minute. But you basically take this hydraulic ram, and there's a hand pump that comes with it. It's out of screen here. It's just too large to fit in the screen. But basically you just assemble all these components, thread them together, and then you would take the receiver that basically the die just fits into. You put that through your piece of metal, and here you see we have a 3/4 inch hole. So we're going to go ahead and do one of these. So that goes in here, and we tighten this all down, and then we take our cutter and we'll just run it down on this end, and you just run them up snug. There we go. Let me get my hose here. Here's the hose. It's got a thread on quick connect for the hydraulic fitting. And we'll stick this on here and snug it up. And I'll try and get the hand pump into the screen here. It's just this hose is stiff, so it's kind of hard to move, but here's the hand pump, and you got a on-off valve, and we just pump it. So I'm going to pump it off screen so you can see the actual punch process. Let me get it upright so you can see what's going on. Here we go. And what you'll see is it's going to draw that in, and it'll pop off of here in just a moment. Here we go. There we go, and we're through. And we've got a nice hole. Okay? So nice, quick, easy way to make nice round holes in sheet metal. So we want to go through, and what we want to do is we want to be able to dimple that. So we just made one. Let's go ahead and take this apart. We'll pull this off, and we're going to put our new pieces on. Now there is one thing I'm going to skip here because it does get to be a little bit of a pain, is sometimes getting the slug out of these can be a little problematic. At times they will form a wavy washer almost on this surface, and it adheres and gets to be a little pain in the butt. Sometimes that's difficult, sometimes it comes right out. So you can see this one, it's stuck in here right now. Not a big deal if you're working with these, just get a screwdriver, pop it out, but we'll put it aside for right now because the point isn't about putting the hole in, it's about creating the dimple. So we can use this to very easily create the hole, and then we're going to replicate the exact same process using our dimple die that we made. So we'll thread this in. And the reason I decided to go this way is so it's something that's small and portable. There's a lot of these that are done, a lot of these dimple dies that are used on a hydraulic press, a Harbor Freight press, even some where people just hammer, put it on the bench. But if you have a piece of material that is, say, in a vehicle or a cabinet or some other location that you can't necessarily get a hammer and a die into, you can't put it on the hydraulic press, this is a really nice, easy way to go. Okay, so we're going to go ahead and do the exact same thing here. Go ahead and put our dimple piece. Okay, we're going to run it through the sheet metal, and you'll see how it centers in that hole right there. And we'll just thread down our receiving end. I might need to put a spacer on here. Let me see. The kit comes with spacers in case. Yeah, you see we got a little bit of play. I actually can do that right there, and let's go ahead. I'll show you that we don't even need the spacer. They do make a spacer that lets you take up room back here, but we'll go ahead and turn this back on, and we'll just start creating that dimple. And hopefully you can see it from the front side. There we go. There we go. Now it's tightening up. And there we go. One dimple created very easily. And you can see how this could be in a vehicle or a cabinet or something else, and very quickly let you create dimples one after the other. You know, I've got multiple holes in here. So let's go ahead, and we just did one. We'll do the other one. This one threaded on. And depending upon which way you put in this arbor, I put the long threads on this, and there is a short threaded end. I could actually save a lot of time threading that on and off by putting it in the other direction. But here we go. Let's put this other dimple in. Okay, let me see if I can hold this up to the camera while this happens. Maybe you can get a better view of that. And it takes very little force. I mean, I'm pumping that off to the side, one hand, while we're talking here. There we go, and we'll release it. Unthread it. There we go. Nice dimples in our sheet metal. All right, so let's get into how we made this. We'll get over to the lathe, and I'll show you how you can make these. They're very, very simple and very quick to make. Okay, so I figured what we're going to do is draw out what we're going to do on the lathe so you can get a better idea of how this process goes. So here's our two components, and we're going to start with the male part first. Let me grab a nice marker here, and we're going to, have our material chucked up in the lathe, okay? And we're going to start making these features here. One of the things I do want to talk about, though, is my choice of 45 degrees for the bevel. And I mentioned that it kind of makes it really easy. What that is when we want to cut this bevel, and I'm just going to draw one here. This isn't where it gets cut. I'm just going to draw it for ease of use here. So if we're going to cut that bevel, and we know that it is a right triangle, and that this is 45 degrees and this is 45 degrees, that means this distance and this distance are equal. All right, so that makes it really, really easy when we go to cut the angles and zero everything out that we don't need to measure anything. So what I'm going to do here is fix this drawing back up, and we're going to go through and illustrate what I mean by that. Okay, here we go. So the very first thing we'll do is we're going to take our boring bar, and we're going to come in with the boring bar, and we're going in reverse at first because it makes cutting the bevel easier, and you'll see why when we get there. And we're just going to come through and we're going to face this whole thing down. Okay. Now we need to turn this registration boss, and that is this one here is 1.68, and the hole is a little over 170. All right, so we're going to do the 168, and remember we brought it down 125. So I'm going to do this in just one pass here, basically, to show you what we would be doing. But we're just going to come in out here, and we're going to go, 125 in, because we just did our zero. We know where we are. Okay, we're going to come 125 in, and we're going to come down until we hit our 168. Okay, now that's going to be in multiple passes. But what that is basically going to do is create this registration boss that we spoke of. Okay, by removing this material. Okay, here we go. So now we've got that, and that's pretty simple. This is obviously not to scale, just drawing this for purposes here. But now we're going to come through, and we have zeroed right here. Right? And technically not zero, I'm using that term loosely. We know we are 125 down, and we are 168 in. So to cut the bevel, all I need to do is move 250 out. Okay, and I know that's the start of my bevel, okay? And I'm going to move 250 in, and that's going to be the shelf for the bevel. So what we can do is very easily start nibbling away at this until we are in 250, and we have come from this surface 250. So we're just going to nibble, 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 and we're going to create another step, okay? So now we're going to have another step in here. There we go. And we've taken this material out. There we go. And now you remember, right here at this corner, we know where we are. We're 168 and 125 in. And we know that this corner is what we want to bevel out. Okay? So we're going to take our boring bar, and we have the compound set at an angle, and we're just going to nibble that corner off. Okay? And just nibble, 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 until we get to this number right here. Okay, there we go. And same thing over here, nibble, 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 nibble. And because it's obviously a circle, so what I do to one side happens to the other. It's the way the lathe works. Okay, and there is our basic profile. Now obviously these aren't to scale. This would probably be a little more like this if I were to try and keep things in perspective a little bit. So we've got this, then our bevel, and then here. Okay, so we've got our representative surfaces. I'm going to draw my line here because we have that smaller circle right there. So that's really all there is to that. And now we can drill our hole. Now I started with the hole, but you can punch your hole right through here. You can do it before or after. Doesn't really matter. And then that part is complete. And that's all there is to that. So let's go ahead and do the female piece. Okay, and we'll draw another piece in here. I'll try to keep this one a little bit more in perspective. All right, same sort of deal. We're going to come through with our boring bar, and we're going to face this off. So now we have a zero. We know where we are. Okay, so what I want to do is the same exact thing as last time. We're going to go ahead and basically start creating that 168 feature. And actually I'm going a little larger here. I'm going 170. But now this one, I do put the hole in first, okay? And the reason I put the hole in first is it gives somewhere for my boring bar to go. So now I'm going to come in, and I've got my measurements. I know where my zero is, and I'm going to nibble out, and nibble out, and nibble out, and nibble out. Now, this piece has to fit fully within there. And you remember that we are 125 here and 250, so we're 375 for the total depth here. So we're going to keep nibbling out until we get 375, and I'm going 170 on here. So internally, we're taking this material out of here. Okay, so now we would be at our 168 well, 170 on this one. It's the receiving piece. We want to give a little bit of room. All right, and we went 375 deep. I actually go 380 on here just for a little bit of extra room. You don't really have to, because once the two pieces come together with a piece of sheet metal in between, it'll automatically create that space. But I like having just a little bit of room in there. Okay, so really simple. I obviously can't just, erase this line because those are internal lines. Okay, here we go. So here we go. And now the exact same thing is going to happen. I'm right here, and I want to go 250 this way and 250 this way. So I know where this number is right here. Okay, I'm going to come back out and go over 250, and I'm just going to start nibbling internally just like that. So I'm going to take a little bit off, a little bit off, a little bit off, and a little bit off. Okay, and that same thing, of course, happens over here. And now we end up with that internal feature. Okay, there we go. And that is the feature that this fits into. Okay? So there is a little bit of a step here. It's hard to draw in dash notation and make it make sense. There we go. That's where I said I went a little bit deeper. So this is up. I'll draw it solid so you can see it easier, even though it's an internal feature. So remember, this is internal. I'm only drawing it solid so it's easier to see. That's the recess that this boss goes into, and you can see where the bevels would mate up. And then this piece of material here is what rests on this registration surface here. So we have this piece in here with our recess that the boss fits into, and of course, everything just comes right together. So that's really all there is to it. So let's get over to the lathe and go ahead and make a couple of these, and you can see how easy this is. So I've sped this up considerably, and we're just putting some indicator marks so you can see this on the camera. And that's our 170 center, 125 deep, and the secondary mark was 250 out from that, as we had discussed in the previous segment. So here we're just driving in, going down our 125, bringing it into our 170 center diameter. And we're going to just go ahead and finish off that center. There we go. And just clean that corner up. A little bluing for you so you can see this a little bit better once again. Okay. And what we're going to do is go to the back side and give you a mark at our 250. There we go. That is the 250 down that we're working towards, which is going to bring us to a 375 total depth. Remember, that initial cut we made is 375, so I could clear the chuck, so I knew where that was at. So we're going to come in and clean up that outside edge and just finish this off here. There we go, and a little more bluing. Couldn't get the marker in, so I'll get the die come on here. So you guys once again can see, and we're just nibbling away that corner. And we're just going to continue to nibble using the compound and the cross slide, and just bring it back all the way till we meet up with the center boss that was our 125 depth. And remember, we brought that to a 168 final dimension. Going nice and slow here, just get a nice finish on this piece. Okay, and that's just about going to do it for us. So we're going to do a little bit more cleanup while we're here. Okay, so let's go ahead and clean up that interior hole just so we don't have a sharp edge in there. And that piece is done. Now here we are on our second piece. You see the 3/4 rod doesn't fit in. The previous one I had shown was tapped. We're going to actually bore this out to 3/4, and I'll explain why later in the summary. So let's go ahead and get a nice surface finish, and that is coming out to our 170. Remember, our 168 was the registration boss. We wanted a little clearance in the female piece, so we're bringing that out to a 170 final dimension. And it has to go at least 375 deep to allow the dies to set together. So we're going to initially bring it out to 375 deep and 168. So when we do our final cleanup, we're going to bring that into a 380 depth and a 170 for a circumference. And we're just about clearing that up here. Okay, and bring that up nice and slow, and there's our finished dimension. And the exact same thing. We're going to go ahead and mark our 250 out, and using our compound and our cross slide, we just keep nibbling away, and you can see that inner cone start forming. And we're just using all the DRO here to just track our position. Since we're going to bring the compound into its relative zero position every time, all we have to do is measure where our cross slide goes, and we know that we hit our number. And there is our female component pretty much finished. So that is literally all there is to it. A little cleanup on the edges, and we're done. Okay, so here we are at the bench, and here's the first set of dimple dies we've shown in the opening, and regular sliding fit and the threaded piece, for punching the holes. And here's the new set we made. All right, a little bit larger diameter. That doesn't really matter that much. It just gives you a little bit more surface when you're, creating the dimple for those two pieces to mate up. As you can see, I haven't cleaned up the outside yet. I'm going to put these on an arbor, put them in the lathe, and just clean them up to pretty them up, take the rough edges off, etc. These surfaces are not parallel. That really doesn't matter too much for what we're doing because these surfaces are parallel and perpendicular to the center shaft. Okay, so when I was over there, I stated I did this a little different, that this took two different size holes, right, a 3/4 and 11/16, and a tap to go ahead and tap this piece. One of the things you can do is you can just make them 3/4 straight through, okay? They'll slide on the arbor, if I can get this thing over here. Boy, it's really stiff. Okay, here we go. Hopefully you can see that well. So those would just slide right on, and then we can put a nut on the end, okay? That'll help considerably. So here's this spacer that comes with the kit I was talking about, just so you can do less threading and move things around if you need to. So what we're going to do is we're going to go ahead and punch this dimple here using the dies we just made and see how they do. Okay. So now the benefit to doing it with a nut instead of a threaded on component, with the threaded on component, this piece must be the outer piece that is drawn because this is the sliding fit. This is the only piece that has anything to retain it to pull in. If you use a nut like this, the dies can go in either direction. So you get a little bit of flexibility there because if this is too big to fit where you want the dimple direction to go, you can reverse the whole thing. So in other words, I can make a dimple up or down from one side of the metal. I don't have to have access to the other side to get this in here. All right, so we're going to go ahead and do that. And we're going to go this way. And, oh, I didn't, yeah, I got enough clearance. I didn't make sure I had enough clearance to the edge for these larger dies. All right, so there's that. And we're going to do it with the nut. Get that in there. We'll get our female piece. We'll put our spacer on for good measure. And our nut. Okay, there we go. We got some tension. And again, we'll get it where you guys can see. See if I can hold that up. Not sure. Maybe it was better there. There we go. And a pumping we go. There we go. Let the pressure off. Take our nut off the back side. Spacer, die, and voila, one nicely made dimple. Very, very easy to do. All right, so this hydraulic method is really nice. It makes the work real easy. One thing you can do, however, is if you don't have this, don't want this, or even just want a smaller, more compact kit, here's your kit. When you don't thread them, and they just have a sliding fit, you can just use a nut and a bolt. Just like the arbor that we have on here, that would go through the metal, and we'll go ahead and put this on here so you can see it. Okay, so this is the back side. We'll put this one on there. We'll drop the male portion on the front. Fits right in there. Oh, and normally I would put a washer on each side, just really to help distribute the force of the nut so it doesn't gouge into our die. That's the only reason for that, just so we don't gouge up the die because they're just mild steel. All right, so let's say hypothetically we hadn't dimpled this yet, and that one is, there's something hanging up on my bolt, unfortunately. But you get the idea of what we would do. I can take a wrench on one side and impact on the other, and just burp and make a dimple anywhere I wanted. These would be really easy to throw in a toolbox. You don't need to have the hydraulics. I haven't tried it by hand. I bet you could probably dimple it by hand just with 2 wrenches, but an impact would make it super easy. Okay. And we're using a grade 5 bolt here. You could use a grade 8 if you wanted to, if you're worried about shearing it, but I'm pretty sure most impacts on a grade 5 3/4 inch bolt, just bending, and this is 16 gauge metal, is not going to have a problem. All right, but there you go. That's our dimple die kit. You can see how easy it was to make those. These are not cleaned up. They're not polished like the first set that I made. And you can see a little bit of that transfer into here. I don't know if the camera will focus on that, but there's a couple lines in there that I didn't get on the other dimples because I polished the dies. All right, that's not really that bad. A quick cleanup with a flap wheel would clean that right up, no big deal. Or when I'm in the lathe, just cleaning up the outside, polish these surfaces. And that's all there is to it. All right, so if you've got any question about dimple dies, different ways to do it, different things we could do, comment down below. I'd love to hear your input. If you've made these and have a different method, I'd love to hear that as well. This is great information to share and get out there, so I hope you guys got value from this, and I'd love to hear from you. Once again, thanks for watching Mountain Laurel Metalworks, and you all have a great day.